One sector that is about to fully exploit the opportunity of 2D barcodes is the Australian healthcare sector. The pandemic has shined a light on the importance of our healthcare supply chains, from personal protection equipment to vaccine and to medicines. Many governments around the world have implemented serialization and traceability regulations to support efficiencies in their healthcare supply chains. In Australia, the Department of Health and Aged Care has started a consultation process to develop a framework for medicines traceability in Australia. And also the Therapeutic Goods Administration, the Therapeutic Goods Order 106 for medicine serialization comes into effect in January 2023, and also requires specifically the use of 2D barcodes. In this case, the use of GS1 data matrix. Our keynote speaker for today, Michael Hadjion from Aspen, Australia, has been on this journey for several years, having been responsible for implementing serialization at Aspen between 2018 and 2020. Michael has 18 years experience in the pharmaceutical industry and joined Aspen as a project manager in 2012. He has delivered a diverse range of projects, including major capital works, contract manufacturing, tender submissions, and the transfer of a large portfolio of consumer and OTC products into this Aspen facility. So Michael is going to share with all of us his experience in implementing item-level serialization, 2D barcodes, and traceability systems based on GS1 standards. A very warm welcome to you, Michael, and over to you.
Thank you very much, Marcel, for the introduction, and thank you to GS1 and NGTAG for the opportunity today to share some of my insights into the topic of serialization and how GS1 standards such as the data matrix 2D barcode are being used to tackle issues of counterfeit pharmaceutical product and to enhance traceability in global markets. Today, I'll briefly cover what serialization is, why Aspen implemented it, and how the system works for us and our contract partners for which we manufacture product. I'll also talk about how the system can be expanded upon and also some of the implementation challenges that can be faced. Just firstly, a little bit about us, Aspen Australia. So we commenced operations in 2001 with our headquarters in Sydney. We're a wholly owned subsidiary of Aspen Pharmacare, which is headquartered in South Africa. Aspen Australia operate a pharmaceutical manufacturing facility located in South Dandenong in Melbourne, which is where I'm based. And we make a whole host of different products, including prescription, specialty, over-the-counter and grocery products, both for local and for export markets. And in the past 4 or 5 years, we've really seen a huge expansion in our contract manufacturing business. Why we implemented serialization? As part of that expansion of our contract manufacturing business, we did undertake a huge portfolio of products that were being sold into export markets, predominantly into the Middle East, but also to the United Kingdom and to South Korea as well. So this was a huge expansion of production that had a future requirement for serialization at the time. We sort of started that journey in 2018. At that point in time, the EU hadn't gone live with their what's called the Falsified Medicines Directive, which was the mandatory timeline for EU countries to implement a serialization of pharmaceutical product. So that occurred in 2019, and we had production that was going live in 2020/2021 that would require serialization in not just EU markets, but predominantly in the Middle East. So that is why we went down the path of implementing serialization. Firstly, what is serialization? And just building upon what sort of Marcel introduced in that space. So serialization as it applies to pharmaceutical products is the application of a 2D barcode onto packaging, which contains a unique identifier. And that unique identifier is traceable from the manufacturer and the brand owner right through to the consumer. And this enables verification of drug authenticity. So at its heart, it's an anti-counterfeiting measure. In most global applications, what is used to carry this is a GS1 data matrix, and this is encoded with 4 pieces of information. Firstly, there's the Global Trade Identification Number, or the GTIN, which identifies what the product is. There's the expiry date of the product, the batch number, and then very importantly, the unique serial number that is applied to every pack. The type of serialization that we implemented at Aspen is what's called the point of dispense authentication, or the PODA model for short. So this is essentially the generation and transaction of serialization data at a sales unit packaging level. And just to sort of unpack what this slide is showing. So in the top left corner, we have the contract manufacturing organization, which is ourselves as a manufacturer of product on behalf of brand owners. And the traditional flow of product, which is shown by the blue arrows along the top there, is that we produce product. It goes into distribution through sort of third-party logistics into export markets, which is managed by our brand owners. That then gets sold into the retail sector, into pharmacies, and then those products end up being purchased by the consumer. So with serialization, there has to be a flow of data that supports that physical flow of product, which is shown by the red arrows in this diagram. So where we produce physical product, we print the encoded data matrix with those elements of information, including the serial number onto every pack. When we sell that to the market authorization holder or the brand owner, we send all the data associated with those physical packs that we've sold to them, and that's essentially what we call the commissioning of the serial numbers. That means we provide the serial numbers with all the batch specific details to the brand owner. And then when the brand owner sells and supplies that product into the markets where they sell that product, they undergo a process called reporting, where they then share the data for those serialized packs into the national database or regional database for that market regulator. So then what that enables is at the point of sale, the pharmacist can scan the data matrix on that pack, and it will authenticate that serial number and the details of that pack against that database, and will verify that that pack is genuine. And it will also potentially check as well that it's not a duplicate, so it hasn't been scanned out multiple times, and that obviously that it exists in that database to begin with. So that's how it closes the loop and provides that anti-counterfeiting measure. Just a snapshot of the markets that we currently supply to via our brand owners, and just to look at how the maturity of serialization progresses in different markets and how it does sort of follow sort of a staged approach. So generally for the export markets, the first thing that needs to be developed is the regulations around how data matrix or 2D barcodes are printed onto packs, and then that progresses to serialization, which is that second column there, where manufacturers have to provide unique serial numbers to be encoded into those data matrix, and that for manufacturers and brand owners to actually generate and maintain data of those unique packs. That then progresses to reporting, which is where the brand owner then has to provide that data to the market regulator to close the loop on product authentication, which would enable those packs to be scanned and verified at the point of sale. The final step of that journey is aggregation, which I will touch on a little bit later on in my presentation, which provides traceability through various stages of the supply chain. So you can see there across the different markets that there's some of them have achieved that full maturity, and some of them are sort of going through the process of getting there. So with regards to the infrastructure that we've implemented at our facility, it follows like a traditional model of the serialization hierarchy, which is talked about levels 1 through to 4. So the level 4, which is otherwise known as the enterprise level system, is we use an application called TraceLink. So this is the system which is the kind of the brains of the serialization system. It's a cloud-based repository where we maintain pools of serial numbers, and it is also the business-to-business interface with our brand owners for sending and receiving serialization data. Sitting below that is what we call a level 3, or a site level server application, where we use an application called Vimichem, which is used for batch management at a site level. It's the layer that we as a manufacturer deal with most often for generating creating batches of of serialized products and then issuing them to production lines. And then sitting below that is what we call the level 2 or the line level controllers, which are really at the cold face of serialization. So they receive the serial numbers for each lot that we need to manufacture. They issue each serial number to each pack. It prints and verifies the packs. And then at the end of the batch, it assigns the disposition of all those serial numbers, whether they were good or bad, to the site level server. I'll get it a little bit more into some further detail on that in the subsequent slide. So that's our infrastructure. When we were going through the process of implementing our system, we did have several selection criteria, and this is, I guess, really important for anyone that is looking to undertake this journey. So one of the key selection criteria we had was around we wanted a system that was flexible. So when you implement such a system, it does become very sort of ingrained in your operation. So we did a lot of due diligence up front to make sure we were going for a system that was going to be very flexible to our needs, and that's where we found a lot of suppliers have very proprietary type solutions, where we sort of went for something with a universal interface that between the different tiers of the system, we could in the future change either the software or the line level solutions and have the ability to mix and match different systems. Scalability was the next important piece. We certainly wanted a system that we could initially deliver the point of dispense authentication model, and then in the future expand on it by either adding more packing lines or more capability onto those existing packing lines to implement fully aggregated solutions. Of course, ease of use was a big factor. There's many stakeholders in the organization that have to work with this system. It has to be quite intuitive and not overly complicated, given this is not just being used by the production planners for issuing batches to lines, but obviously all the factory operators have to work with this system as well. What I call a balance of ubiquity and innovation. Obviously, you want to sort of go with tried and tested solutions, but also given there's sort of early adopters in other countries where they've had milestones for delivery before us, we've had the opportunity to kind of learn from other companies, implementation challenges, and also look for options that sort of gave us a bit more innovation to get around some of the issues that other people have had when they've implemented serialization solutions. Implementation support from suppliers is important, and the customer service from the different serialization solution providers. So that was a big factor we considered. And then, of course, as well as the cost, both of implementation and ongoing costs as well for the solution. So in terms of the workflow and just sort of breaking it down at how it works for us as a contract manufacturing organization, it begins with TraceSync, which is our enterprise level solution. And within that, we maintain a pool of serial numbers per product, so essentially per GTIN. And that pool is replenished from our brand owner. So it essentially has a minimum maximum threshold. When we draw down that pool and it goes below the minimum threshold, it automatically gets replenished from the brand owner's enterprise level system. When we're ready to produce a batch of serialized product in Vimachem, in our site level serialization system, we create a batch, we assign a quantity to it, and then automatically it draws down from the cloud-based pool the required number of serial numbers, and they essentially get into a reserved state in TraceSync, which means they cannot be inadvertently allocated to any other production batches, so that makes sure that those unique serial numbers are only assigned to that batch. When we're ready to actually produce that batch physically on the line, from Vimachem, that batch is assigned to the production line, and all those unique serial numbers are then pushed down to the line level or the level 2 system. Then when we're physically producing the packs, we're in this example here, there's an image of one of our blister lines, so we're producing packs of pharmaceutical product. They roll through this machine. It typically applies tamper-evident labels to the packs and then prints the unique barcode and human readable text onto that pack, and then immediately acquires an image of what was printed on that pack, decodes that data matrix, reads all the human readable text, and makes sure that it was printed correctly and decodes correctly. And if all that's good, then that pack is accepted. It rolls off the machine. If there was any issue with that pack and how it was produced, it rejects that pack automatically, and also marks that serial number as not okay, which is the terminology used on that machine. And you can see the screen there as it sort of keeps track of the packs, classifying them as okay or not okay. So then once the batch is finished, we close the batch on the line. It then sits at that site level server application And then essentially for that batch, we end up with a certain number of accepted packs for which were saleable, a certain number of rejected packs for which the serial numbers were classified as not okay, as rejected, and then there will be always a residual amount of serial numbers that were not used. So then while batch release is pending at our facility, the serial numbers and their disposition is held at a site level, and just to provide clarity, still at that enterprise level in TraceLink, that set of serial numbers that were assigned for that batch are still sitting in a reserve state. That is, their final disposition has not yet been assigned while we're still performing batch release, because of course there might be the risk that we, for some other reason, need to reject that batch if something else has gone wrong, and then in that case, then all the serial numbers would be deactivated. So once quality release occurs, that batch essentially, we use the terminology, it gets commissioned into TraceLink, and then the final disposition of all those serial numbers that were associated with that batch of product get assigned. So all the accepted batches, accepted serial numbers for saleable units get commissioned in TraceLink. All the rejected packs, those serial numbers get deactivated, and then any of the residual serial numbers that were not used essentially get changed from a reserve state back into a unreserved state in the pool, and they can then be allocated to future production. The final stage of the contract manufacturer workflow that we follow, when we actually physically export the stock to our brand owner, we then send them the data associated with those packs as well. So that final step is called a shipment transfer event, and that is encapsulated in something called a GS1 electronic product services information file, or an EPSIS file, and that contains all the event data that supports the commissioning of each of those packs. So that includes the time and date stamp of when that pack was commissioned, where it was commissioned. So it has a global location number, which is another GS1 standard of where it physically was commissioned. So in our Aspen facility, and a product owned by our Aspen company, and that it shows that that product was then shipped to our brand owner, and it includes their GON information as well. So it sort of captures that movement of product from one entity to another entity. So having first implemented the PODA model, so serialization at a sales unit level, the next potential thing we could implement is what's called aggregation, or otherwise known as full track and trace, where serialization does not only occur at a sales unit level, but it also occurs at higher packaging levels. So things like potentially at a bundle level, at a case or shipper level, or at a pallet level. So with aggregation, it does require sort of more equipment and more sort of systems on each line, and it also does require more capability through your supply chain to sort of monitor the movement of stock distribution. But essentially what this allows you to do is establish child to parent relationships between your high level packaging components, so things like a pallet, right down to your sales unit. So by tracking the movement of a pallet through your distribution, you can essentially then have visibility of each individual pack through your complete supply chain. So I guess the system Aspen have implemented, it can easily be built upon to achieve this, but we're sort of not yet at that level. So I guess the implementation benefits, I guess first and foremost, is the mitigation of counterfeit medicines in global markets, and that essentially achieves increased consumer safety, which is is what the heart of serialization. As a manufacturer in Australia, it's obviously opened up our ability to export into pharmaceutical markets around the globe, which many of them now have mandated serialization and have got a common requirement for GS1 data matrix barcoding as part of that serialization solution. So it's really good for us as a manufacturer to be able to supply almost anywhere in the world now. It's also the first major step towards going to that next step of having a fully aggregated solution. Some of the implementation challenges that we faced and that I think most people would face going down this journey is the validation scope. So essentially verifying that the system works as intended is quite an extensive exercise. Obviously, there's a lot of regulations, quality regulations around the implementation of such a system, so that the documentation and verification is quite a big workload. Obviously, there's a lot of stakeholder management, both internally to the organization, externally, as well as, because it is a multi-tiered system, there's a lot of different solution providers involved, and this system touches a lot of the different departments in your organization, which flows into the generation of operating manuals, SOP, and then user training and embedding all those workflows. So it's quite an undertaking, but if well managed, the journey is of course well worth it. So just to summarize, we started our journey in sort of late 2018, and our system went live in July 2020. So it was about a 2-year implementation, with a big portion of that being sort of fact-finding and doing quite an extensive tender for the solution that we wanted. We now have 5 packing lines serializing product, and we're actually in the process of adding 3 more serialized packing lines by 2023. So we will have 8 lines running with this capability. So finally, this is my final slide. So essentially, Aspen have worked with GS1 to do a bit of a case study for our implementation. It goes a little bit more in depth as to sort of our implementation journey, and that will be published as part of the GS1 healthcare reference book for next year. So those sort of wanting to learn a bit more about our journey, you're welcome to look that up, and I'm sure through this forum some further detail might be provided. But thank you very much for the opportunity to talk today.